Welcome to the lesson for Module 61 on assessing intelligence. This module is the most important for your test, for the unit. Most of the plurality of the questions will be from this unit. So please pay close attention and take notes as needed. All right, so let's talk about the origins of intelligence testing. The first person to try to make an intelligence test, this was in the mid to late 1800s, was Francis Galton. He wanted to determine why individuals differ in mental ability. His four subscales for his intelligence tests were reaction time, sensory acuity, like how sharp your senses are, muscular power, and body proportions. As you may imagine, these four subscales do not correlate with our understanding of intelligence or ability. So to use terminology that we'll have again towards the end of this slide, these PowerPoints, his test had poor validity and poor reliability. It was not a good test. However, it gave us the idea. Francis Galton's contribution was that it gave us the idea that intelligence testing is a thing, that there is some way of assessing intelligence. He also gave us the idea of nature versus nurture that we've been talking about since before the class even began. He was kind of the one who coined that idea. And his book, Hereditary Genius, he believed that intelligence was inherited, that it was nature. Okay, so the first modern kind of like valid intelligence testing was done by Alfred Binet. And Alfred Binet was a Frenchman and who had a very noble goal. He wanted to figure out what students in France needed extra help, kind of like what we would call today special education. How do we know which students in French schools require this education in a very objective way? So he developed the term, he didn't develop the term IQ, that was William Stern, but he talked about the concept of a mental age, a measure of intelligence not by how many years you've lived on Earth, but by how you knowing the amount or having the mindset that's typical of someone of a given age. So if you're 9 years old, and you're as smart as an 11-year-old, you're able to think and learn as well as an 11-year-old, you are ahead of the game. And if you're a 9-year-old who's kind of resembles the mind of a 7-year-old, maybe you require special education. So you may have heard of the Stanford Binet test. Stanford, named after the university in Stanford, California. And Binet, named after the original test. This is the American revision of Binet's original intelligence test. Louis Terman was the American at Stanford University who adapted the test for America, but he had very different motives. He was not trying to help people. He was not trying to figure out who needed special education. He was trying to figure out who was naturally dumb, naturally unintelligent. A lot of this was used in terms of determining who should be recruited for World War I in America, who's intelligent enough to be a good soldier, and a lot of it was used in terms of immigration. Who should we let into Ellis Island? Let's give them an IQ test. If they can pass, they're intelligent enough. If not, they should not be allowed in our country. So whereas Binet believed in a nurture approach, that if you have low IQ, it doesn't mean you're unable to learn. It means we need to give you special education to help you learn better. Terman believed in a more nature approach. Either you're born smart or you're not. That's it. The intelligence with which a person was born. Moving on. So this one we said was Stern. Stern was the one who developed this formula for IQ. Mental age divided by chronological age times 100. So if 100 is considered average. So if you are 10 years old, if you're 8 years old, but the types of answers you give, the types of responses and feedback you give on the intelligence test are more typical of a 10-year-old. So that's your mental age, the age at which you're functioning. 10 divided by 8 times 100 equals 125. Now, we don't use this formula anymore for a variety of reasons, but one of them is that it does not work for adults. Think about it. There's the mental age of a 30-year-old versus 40-year-old versus 50-year-old is about the same. We don't gain intelligence or abilities per se from age 30 to 50. from age 7 to 9 or 9 to 13 for sure. But for adults, this formula doesn't work, which is why we're going to talk a little about in a few slides how we norm and standardize modern intelligence tests. First off, let's just separate two very different types of tests. Intelligence tests are examples of aptitude tests. They're tests that are designed to predict your future performance, your ability to learn, your ability to manage things. So an intelligence test is an example of that. The SAT is an example of that. Very different from an achievement test, like the AP Psych exam you'll be taking in just a few months. That's assessing what you've already learned. If you look at this scatter plot, you can see a strong correlation between someone's IQ on the y-axis and someone's score on a... oh, I'm sorry, actually. I'm misreading that. Yeah, this is between the IQ and... Sorry, my slides are a little messed up here. I can't see the bottom there. But I believe, yeah, these are between the SAT scores and the IQ scores. There is definitely a correlation between achievement and aptitude test, although it's not perfect. All right, so let's go to the modern IQ test. That would be the Wechsler Adult Intelligence Scale, known as a WAIS, or the Wechsler Intelligence Scale for Children, known as a WISC. Ms. Mardek, our school psychologist, will be coming in on Wednesday to talk to us more about this. But there's 15 subtests, 15 subscales having to do with vocabulary, block design, letter number sequencing. This focused mainly on logical and linguistic intelligence, not the other 6 forms of Gardner's theory of multiple intelligences. This mainly focuses on the 2 types of intelligences that are measured in school. So the results, you get your IQ score, and you get a score for verbal comprehension, perceptual organization, working memory, and processing speed. Again, all abilities that are typically tested throughout the school day and curriculum. So as we said, we no longer use that formula of mental age divided by chronological age. So how do we determine what score on an IQ test, what raw score determines your IQ? Let's say you get 80% of the questions right. Does that mean your IQ is an 80? No. Does that mean it's 120? We don't know. So we have to use something called standardization, defining uniform testing procedures and meaningful scores by comparison with the performance of a pre-tested group called the standardization sample. This is going to happen on your AP test. Your AP Psych test is being given right now, this December, as the final exam for Intro to Psych classes in colleges across the country. They don't know they're taking it, so they can't tell their high school friends, hey, I just took your AP test and I know what the questions are. But they're taking it in order to be that pre-tested group called the standardization sample. Based on how they do on the test, that will determine which questions that they actually put in the AP test and which ones are considered easy, medium, and hard questions. They will also use that to determine a normal curve. Please review this from back in September when we learned this. You need to know all of these things again about normal curves, means, standard deviations, z-scores, how to calculate all of that. Know that there's 68, right, between here. We know that there'll be 95 between here. All of those old terms and old facts are coming back. So intelligence tests, the reason why they're coming back is because intelligence tests are scored on a normal curve. The Wechsler, WAIS, any of the main tests are scored with a mean of 100, standard deviation of 15. So if you're at 115, you're at a z-score of +1, and that means you're at the 84th percentile, right? So please remember that from the past, and if you don't, this is an excellent time to review. All right, so I just scribbled on the last slide, but here's all those figures for you. The normal curve, screenshot this if you're looking on your phone and you think you may forget. Flynn effect. All right, this is a very easy term. The Flynn effect, founded by James Flynn, realized that intelligence scores were improving throughout the years. What today would be 100, someone who would score 100, the average, the mean on an intelligence test, that person would have had an IQ of 115 or 130 back in the 40s, 50s, or 60s. Our average intelligence is increasing. So therefore, in order to keep the scores the same, we have to norm them. That's why every year they constantly renorm the scores. We want the average person to get 100. Even if that person getting 100 now would have gotten 130 back in the 20s, we want the 50th percentile needs to be 100. The 84th percentile needs to be 115. The 98th percentile needs to be, 130. So that's why we norm these tests to figure out where everyone scores. All right, this unit, like I said, is a lot of review. So this is a review. The term reliability is review, but these types of reliability are brand new. So to review, reliability is the extent to which a test yields consistent results. So look at these kids taking this test here. It doesn't matter what kind of test it is, IQ test, SAT, psych exam, whatever it is. If these kids take the same test next week and the week after and the week after that, and they get the same scores, we would say that test would be high in reliability. So there's different ways of calculating reliability. And what we just mentioned was test-retest reliability. Taking the same test over and over and over again would be test-retest reliability. But what if we want to just give them the test once? How do we test reliability? We can do that through split-half reliability. Let's look at this kid. Is his score on numbers, let's take the 100-question test, is his score on questions 1 through 50 the same as his scores on 51 through 100? If he's the same percentage for both, we would say it has high split-half reliability. You also could do split-half reliability by separating the even and the odd questions and calculating an average of both of those. Validity, another term that we're reviewing, but we're going to go into more detail about this as well. Validity is the extent to which a test measures or predicts what it is supposed to. So an intelligence test oftentimes is very high reliability, but is it really measuring your intelligence, right? Whatever it's measuring, you're getting the same score roughly each time, but what is it measuring? And there's different types of validity. This is going to go into more depth than we did back in September. Content validity is the extent to which a test samples the behavior that is of interest, the extent to which the test actually tests what we want it to. So if I give you a unit test, I just gave you a unit test on social psych, and am I covering information from all 7 modules in social psych? Am I covering information from only one module? Or am I covering information that was in none of the modules and that was on biology? If I'm covering either not all the information or I'm covering extraneous information, that test would have low content validity for social psychology. If social psychology knowledge is what I'm trying to measure, I need to have almost all the information about social psychology, and it needs to cover every aspect, every module within social psych. Face validity is kind of the same thing as content validity, but on a more superficial level. Face validity means I'm not going to actually look through the test and make sure I have information from every single module and tabulate how many questions per module. I'm just going to flip through it pretty quickly and see if it looks kind of on the face of it, right? That's why it's called face validity. It looks like a quick glance like it has good content validity. Predictive validity is the success with which a test predicts the behavior that's designed to predict. So an example of that would be the SAT. Is it predicting how well you're going to do in college? It's not testing what you've already learned. It's predicting how well you're going to do in college. Does it do a good job of that? It does not have perfect predictive validity. Many people who do excellent on the SATs struggle in college for a variety of reasons, and vice versa. Those who struggle on the SATs may, really flourish in college, which is why colleges have started looking at other factors in the admission process, like your essay and recommendations, your grades throughout the 4 years. It's not all about the SAT. So concurrent validity, look at the word current, it's your hint, the extent to which a test accurately measures how much of a characteristic a person has now. So if you're in school to be a pilot, right, I give you an exam on, let's say, I want to see how well you can fly a plane. If I'm giving you that exam in order to know that I can put you on a plane tomorrow, That's a test of concurrent validity. If I'm giving you an exam to see if you're going to be a good candidate to be in flight school and fly a plane in 5 years, that's predictive validity. Construct validity. This is the most meaningful kind of validity. It's also the most confusing. If there's an independent measure that already exists that has been established to identify anything, we now can correlate, and there's an example here I'll go through in a moment, but we can correlate your new measure with that measure. So if there's already, talking about chefs, right? If there's already a measure to establish or identify those who will make fine chefs, we can correlate the prospective chef's performance on this measure with their performance on any new measure. Better example, more relevant example. Let's say the SAT has perfect validity. We just said it didn't, but let's just say hypothetically, if the SAT has perfect validity, now we can have a newer test, like the ACT is a newer test. We could have someone take the SAT and the ACT. Now, assuming that the SAT perfectly predicts how well you're going to do in college, we can correlate your score on the ACT with the SAT and be like, hey, if you scored high on both, then that proves that the new test, the ACT, by extension, also has high validity. So this is the most meaningful kind, but it's the hardest because it requires you having one test with near perfect validity in the first place, with which we almost never have. All right, so these slides are not in your book, so please pay attention here. Again, feel free to screenshot. We talked about these terms already. These last couple slides, I'm going to review them with you because they're super important. Standardization. All standardized tests, obviously, but must be standardized. All intelligence tests must have standardization, reliability, and validity. Standardization means that we're using uniform rules for administering, taking, and scoring the test. Right? Everyone sits down for exactly 75 minutes. They have given 3 pencils. They're in a room by themselves, or they're in the room with no more than 10 people. They read the instructions. They tell you they remind you halfway through that you have 37 and a half minutes left. That's to be very specific. Think about an operational definition. Standardization is basically an operational definition for an exam. The other thing a standardized test, an intelligence test, must have is norms. Norms are the performance benchmarks established during test development used to establish the average performance. So let's say an IQ test is out of 50 questions. If you get 45 right out of 50, what's your IQ? It's a trick question. You can't answer that without more information. You got 90% of the questions right, but what does the average person get? Because we had some standardization group that took the exam before you did, or took the IQ test before you did, and out of those people, let's say the average was getting, 30 right out of 50. If 30 right out of 50, and now what's a standard deviation? Standard deviation was 10 questions. So that means that 30 right out of 50 would be an IQ of 100. And every 10 questions different, right, would be one standard deviation. So one standard deviation above of IQ is 115. So that's how we would determine where your score fits in the normal curve. We need norms to do that. We want a representative sample. The group that is used to establish norms should reflect the demographics of those who will eventually be taking the test. That's why current college freshmen who are taking Psych 101 at universities across this country are a perfect representative sample because they're taking the exact same course you are. They're roughly the same age you are, a year older. So the way that they score on that test will be representative of how well you will score on the test. And so in this case, the representative sample, in this case, the standardization sample is representative, which is what we want. That's the group that determines the norm. So that, in this case, was the college students taking the AP Psych, the AP Psych exam as their final in December for their class. All right, so we have the normal curve here again. We don't need to go over it, but please memorize that if you haven't done so already. Scores should be distributed in any standardized intelligence test. Scores are distributed in this bell-shaped curve. Most people, right, you know how many, 68%, will fall between 85 and 115. Due to the Flynn effect, like we said before, the intelligence test must be continually re-standardized to keep the norms valid. You can't be scored along with a standardization sample from 1960 because then people's intelligence will lower due to the Flynn effect. And by the way, before we go to reliability, the Flynn effect, there's many reasons for it. Many people think that because of our advanced technology, our brains are just sharper because we're on our screens, we're on TV, we just so much was saturated with so much information on a daily basis that it forces our minds to work faster and harder, and that's why our intelligence actually increases. We went through this before. One more type of reliability I want to throw in here is equivalent form reliability. So we discussed test retest, right? Taking the same test over and over again and then comparing scores on each trial. Split half, right? We divide in half. Either we do even odd, or we do the first 50 questions, second 50 questions, average those separately. Do we get the same average? Third type is equivalent form reliability. Because your obvious question might be, hey, if I take the same exact version 10 times, it's not going to have reliability because I'm going to learn over those times what the questions are. So equivalent form reliability would be giving, like, that's what taking the SATs multiple times is. You're never given the exact same questions. So this example of this would be SATs. You're never given the exact same questions, but if you're getting like 1,200 every single time you take it, we'd say that the exam has equivalent form reliability. This was a lot of information, I know. Please also outline in the book that because you need, I'd say, the visual and the auditory to really understand this. We're going to go through this more through examples tomorrow. Have a great night, everyone.